Hello. As a reminder, this was 10-1 day 1 we did the other day. I'm recording this on Tuesday morning. This is just to reinforce and to go over what we were talking about yesterday. So 10-1, we are starting probability. This is day 1 content. So we're talking about sample spaces, and that's going to be the list of total possible outcomes of an event. So for example, if we flip a coin one time, we can get either a head side or a tail side. And so your sample space would be 2 possible outcomes. And if you roll 6-sided die, we can roll a 1, 2, 3, 4, 5, or 6. And that would be 6 possible options for your sample space. Tree diagrams are another way to represent your outcome in the sample space. And if we flip a coin 2 times, your first flip could be on heads, or second flip could be on heads. So we would have heads and heads, or your first flip could be on heads and second flip would be on tails. So we get heads and tails. Or your first flip could be tails, but second flip is heads, so tails and heads. And your first flip could be tails, and then second flip is tails, so tails and tails. So we have 4 different outcomes. And notice when we have that coin flip 2 times, we're having 4 different outcomes. And that's going to lead us to this fundamental counting principle, because if we have one event that can happen n number of ways, and a second event that another one can occur in n number of ways, we can multiply the number of ways that can occur to get m times n possible outcomes in that sample space. So this coin being flipped 2 times, we had 2 different ways to get heads or tails. For each of these twice, so 2 times 2 gives you 4 different outcomes. If we flip a coin 3 times, the first flip, we have 2 outcomes. Second flip, we have 2 outcomes. And third flip, we have 2 outcomes. So 2 times 2 times 2 gives you 8 possible outcomes. When we go to look at these all these examples here, I'll just reinforce just a couple of these. If we flip a coin and roll a 6-sided die, the coin flip has 2 possible outcomes, and the 6-sided die has 6 possible outcomes. So we multiply both of those outcomes together, because the one event times the other event gives you 12 possible outcomes. And here is your sample space off to the side. We can roll a 1 and get a heads, or we can flip heads and get a 2, and so forth. Or we can flip tails and get a 1, flip tails and get a 6 even. So we have here 12 possible outcomes off to the side. If you need to stop and pause for a moment, go on ahead. Moving on, we have probability of an event we talked about, and that's the measure of the likelihood or chance that an event will occur. The notation we will be using of event A is probability of A, P of A. That number that describes the likelihood ranges from 0 to 1 inclusive, and we can also express that as a percentage, 0% to 100%, respectively. That probability can be written as a fraction, decimal, or percentage. And we can find it by looking at the favorable outcomes. What do we want out of total possibilities, which is going to be your sample space typically? So we have a marble that we want to pull out of a bag that contains a red, yellow, and a blue and an orange. Probability of pulling a blue just means that we have 1 blue inside the bag we can pull out, and we have 4 total. So we have a 1 in 4 chance, or 1/4, which is equal to 0.25 or 25%. Whereas if we have a green that we want to pull out, well, there are no green in this bag out of 4 possible, so it's 0/4 or 0 or 0%. It is impossible to pull a green marble out of the bag. When we go to roll 6-sided dice, and we have combinations of multiple, we want a probability that the sum of the 2 dice is 9. Well, there's only 2 ways we can make 9 with a 6-sided die. That's 4 and 5, or 6 and 3, or 5 and 4, and 3 and 6. And out of possible ways that we can make those combinations, we have 36 total in your sample space. So we have 4 possible ways to make 9 out of 36, or 1/9, which is 0.11 equals 11%. Part B, we are looking for the sum that's greater than 7. So off to the side, I wrote a little table with this top being 1 six-sided die, the other being the other six-sided die, this column. We can have as little as 2 or as most as 12 when we roll 2 six-sided die. So we'll focus only on just the 8, 9, 10, 11, or 12. That is 15 possible outcomes out of 36 total possibilities, which becomes 5/12 or 0.42 or 42%. When we are looking at deck of playing cards, remember a standard deck of playing cards is 52. So that will be your sample space for each of these typically. And we want the probability you draw a heart. Well, that's one of 4 suits, and there's 13 hearts in a standard 52 deck of playing cards. So we have a 13 52 chance of 1/4 or 0.25 or 25%. So if I go to draw a heart, I got my heart here. It is a 1 in 4 chance or 1/4 chance of 25%. Then we want the probability that we pull a face card, which is Jack, Queen, or King, and that's 4 suits, and that is going to be 12 faces together. So we have a 3 in 13 chance of pulling 23 or 23%. So I go to draw my card. 23% is unlikely, so I did not draw that face card. I drew a 3 of diamonds. Then if we look at probability of pulling an ace, there are 4 aces in a deck of playing cards, and that's 4 out of 52, or 1 in 13, or 0.08, or 8%. So if I go to draw, there's my ace of hearts. That is one of my aces. That is a very unlikely chance, but I did draw that ace of hearts out of this deck. Moving on down to these two we did not get to. We have data given to us. So we have this pie chart showing movies that students prefer, and we want to know a student chose at random what that chance of that they prefer action. So we want to add the total first. So we get 26 total students in the survey. Probability of action movies being picked is 6 students out of 26, or 3/13, or 0.23 or 23%. Number 5, we have data of US adults with pets, and 1,832 adults were shown. That is your total. Probability that we choose a bird owner is 93 over 1,832, or 0.05 or 5%. And these are all your theoretical probabilities that we just calculated. Experimental is based on repeated trials of a probability experiment, so these are going to look more like what these were here. We have data that was already collected. So we need the favorable outcomes over total number of trials. So it's going to be varied, because if we look at theoretical probability of flipping a tail in this trial of 10 times flipping a coin, the theoretical, what we found before, is just 1/2. If we look at the theoretical if we look at the experimental probability, we have our trials off to the side. We have 8 heads and 2 tails. Well, we flipped a tail twice out of 10 possible trials, which turns into 1 out of 5, or 1/5. That's the experimental probability. And then I will stop the pause here for the table on number 2. Hopefully this makes sense as well. Notice that the theoretical is going to be what we found before up top with those first several examples. The experimental is based off of the trials. So 20 times what the trial that we spun that spinner. So that's going to be the total there. Number 3, we roll a 6-sided number cube 25 times. Then we found it landed on 2 6 times. So the theoretical first is rolling a 2. That's one number out of 6 numbers. So we get 1/6. And the experimental is rolling a 2. Well, we rolled it 6 times. So 6 out of 25 trials, or 6/25. That is all of 10-1 day 1 today. If you have any questions, please let me know on Schoology. Otherwise, we will continue further with 10-1 day 2 to follow.